Okay, we are continuing on with lesson 3.6. This is part 2. We are doing a sinusoidal regression currently. We've loaded our lists, and now we're going to take a look at what our lists look like. So, I've got my lists loaded. We are now going to do a sinusoidal regression. We're going to hit Stat again, Calculate, and then we're going to scroll up with the up arrow to find letter C. You might have another one, D, in there, that's fine, but make sure you go to Sin Reg. Okay, so find Sin Reg, and we're going to hit Enter. Now, if you've got that other one, it might say number of iterations 3. Leave that one at 3. Then it might say X list, Y list, list 1, list 2, and then it'll say store regression equation. Where it says the store regression equation, that's where you hit the vars button, over to Y vars on the top, and then enter 3 or 4 times. Okay? Now we've got all 4 parameters. Okay, the A number, the B number, the C number, the D number. So we're going to write down exactly the numbers that we have here. Okay, so we end up with an equation of Y equals, not that guy, 20.668, 20.668, and then we write the word sine, we open a bracket, and now we're going to put our B letter, or B number in. So our B number to 3 decimal places is 0.233. Perfect. So we're going to write 0.233. That one gets the X. Now we're going to write the C value. What is our C value? Well, let's take a look. Our C value is negative 0.002. So negative 0.002. Negative 0.002. Close our bracket. Okay, we're going to close that bracket there. Now we're going to write the D value. I'm just going to make this a little smaller for you. Nope, undo. Okay, and the D value, let's see how big our D value is, 38.359. Okay, so we get positive 38.359. Move that over again. 359. Okay, so every parameter is rounded to 3 decimal places. So our first number is our amplitude. Okay, if I want to know my average, okay, if I'm looking for my average temperature, and they're often going to ask you for an average temperature. Whenever they ask you for the average, they're always asking for the D value, okay, the midline or median. So whenever they say, what is the average of this, they're literally asking you, do you understand what the D value is? Now, why do we refer to the D value as the average? Because it's the average point, the middle point between the 2 Y max and mins. Okay? They take them and then they average them. They add them, divide by 2. That's how you get your middle midline. Okay. Let's now find out, we need to find out what was the temperature on February 6th. We see February 6th here, where I've got it crossed out in red. February 6th we're supposed to find. Now, we're having an X number. We know the X number is 37. We don't know the Y number. So this is where we're going to our calculator, and we're going to go second trace. So, hit your graph button. If you don't see a graph when you graph something, always hit zoom 0. So I'm going to hit zoom at the top, 0, and that's called the fit graph. It's going to show me my wave. So, I'm just going to check my window to see if I can see as big as it wants. So, my X maximum is only going to 10. And I'm going to ask it about number 37. Can I see up to 37? Not for my X's. My X's only go to 10. Remember, your circled numbers that I have here, those are all X numbers. So X numbers have to go to day 37, and we're also going to ask it about day 61. So if we're going to go up to day 61, I might want to see up to 70 or 65. And I'm going to count by 10s just so we have less little increment notches. Now, our Y minimum, I'm just going to take that and go to -10 just so we can see our x-axis, or y maximums at 59. That seems to be okay. And we'll put our scale at 10. Okay? All right, everybody can pick graph again, and we should see more waves. Now, a good rule of thumb is in Y2. A good rule of thumb is to put in the D value. So what I would do to my graph is I would go down into Y2 now, and I'd put the D value, 38.359. And then you're going to see your D value come across, and that's going to split your graph. Okay, I will come check yours in a moment. Okay. Once we've got it at this point, we're going to do our second trace. So second trace, number 1. We know the value of x. So we're going to type in, we want to know what day 37 is. So we're going to type in day 37, and we're going to get 53.064. So 53.1. So we're at 1 decimal place here. So now we know this number here is 53.1. We can put that number in. Okay, that's 53.1. Okay? Now we're going to find the next one. The guy I have crossed out here in red. We want day 61. So we just found day 37. It was 53. Now we're going to find day 61. We're going to do it the exact same way because it's an x number. So we're going to go second trace, number 1. X is 61. Whoops, 61, not 4. And we have 58.93. So 58.9. Okay? So that's how we would solve these ones. If they asked you about a y number, you would put that y into y equals, and then you would find the intersects on those. If this question said to you, how many times does it touch the x-axis, or how many x-intercepts does this function have? Does it even touch the x-axis? No, it doesn't. So this one you would say does not touch the x-axis, so it's got no x-intercepts. Okay, simple as that. What we're going to do next is we're going to go into now analyzing an equation. So we started this yesterday. We're going to restart, and I'd like everybody to watch up here. I'm going to do a demonstration with this graphing program called Desmos. You can actually load this. It's got an app to your calculator, and there's a TI-84 calculator you can do for an app as well, actually. They work fairly well. This one, I'm going to type in my actual function. We're going to compare everything to the graph sine of x. Okay? So right now, when I type in sine x, we're going to see exactly what's going on here. I'm going to zoom in a little bit more so we can see what's going on. Okay? Now, if I want to enter another equation, because we're going to compare everything to this red graph. Okay? Now, right now, with our red graph, this is our basic sine graph. So that means that its amplitude is 1 and its midline is 0. Now, why is the amplitude 1 and the midline 0? Well, what number is hiding in front of the word sine? A hidden 1. Well, that means the amplitude is 1. Okay? If there's no c value, it's like saying plus 0 in brackets plus 0. So there's no c value. It didn't move left or right from 0, 0. As we see, it started right here at 0, 0. Then, if we go plus 0, 0 is the midline. That means he is starting right on this x-axis. Okay? Now, the next function I'm going to type in, one more function. We're going to compare the function to a different amplitude. We're going to change only one number at a time. So, taking a look at our notes, when we have our notes beside us right here, right there. So I want to compare right here the a value. So I'm going to change the a value, okay? And we're going to see what changes about the graph. Then over here we're going to change the b value. Over here it should be saying plus c. It's a typo. It should say plus c in brackets like that. And we are going to check the c value. And then in this one, we are going to check the d value and see what it does to the graph. Okay? So, back to our graphing. When I take a look at my next function that I'm going to add, let's add me a function in here. I'm going to change my amplitude to 4. for sine x. And what do you notice they've done to the graph? Does it have the same x-intercepts? Yes. Does it have the same period? Well, let's take a look. If it's got the same x-intercepts, it's got the same period. Okay? So, this guy's got the same period. He's going to make one full wave in the same amount of time. The only thing that's changed is the peak of their graph. Their maximum is a lot higher, and their minimum is a lot lower. So all that changed on this, if we were compared to real life as a tire, the one that's sine x, we would say that's a bike tire, a small tire. The one that we see here in blue, we would say that's a car tire. It's a lot bigger than a bike tire, okay, if we compare them that way, okay? We could also compare it to a large truck tire versus a car tire, okay? So, changing the value of your amplitude, all it's going to change is your maximum value and your minimum value, okay? And it changes your amplitude. That's what it's changing. So that's like the radius of your tire. Now I'm going to go back in, and now we're going to change the b value. That's the number that's sitting in front of x. So if I take a look at the red function, it's got a hidden 1 sitting in front of the x. So that's 1x. We're going to take a look at, what if I change it to a 2? Let's see what happens. Well, what did our blue graph do? What do you notice? Does it have the same x-intercepts? No, it does not. Does it have more x-intercepts or less? Way more. So we're seeing more waves of the blue one than we are of the red one, correct? So if we're seeing more waves, if you're comparing tires, right now their amplitudes are the same. If the amplitudes are the same, that means their tire's the same. Okay, same size, same radius. So if their tires are the same, all this means is somebody's going faster than the other guy. So which one's going faster? The blue guy. Okay, the blue one's going way faster. So if we change the b value, the period changes. It either moves slower or it moves faster. Okay? So let's change the b value to a fraction. Let's change it to 0.25, 1 over 4. Wow, what do you notice? What happened to our graph? It got really wide, okay? So we're seeing not even one full half turn. So right here on the blue where I'm tracing, we can only see not even a full half turn. So it's completely widened. So that's changing the b value. It's changing its period. That means it's changing the speed of your vehicle, because the period is how long it takes to get there. So if you're talking about vehicles, how long it takes to get there, one of them that's going faster is going to get there first. Okay?
So that's following the same rule if it's greater than 1,
Yes. So if it's less than 1, if it's a fraction, it's going to be a wider graph. If it's greater than 1, it's going to be going faster. So you're going to see more waves if the number's greater than 1, so you'll have a faster wheel. And if it's between 0 and 1, because the b value will always be positive. Our a values and b values will always be positive. That's something we have to remember for dash 2. A values and b values are always positive. So what we're seeing is, if your a value is between 0 and 1, a fraction or decimal, it's going to be a wide graph and he's going really slow. If it is greater than 1, so 1.5, 1.1, 1,000, anything bigger than 1, it's going to be going faster and you're going to see more waves. Okay? Let's take a look and see what the c value does. So I'm going to change our b value back to 1. So we're just going to have x, but the minute we put a c value in, we need to include brackets. So I'm going to open a bracket. Now I'm going to put my c value. So x, let's just go plus 2. And what happened to my equation? What do you see happened to the blue one? What did he do? What do you see? Yeah, it shifted. Did it go up, down, left, right? What do you think? It went to the left. Now, the reason we know it went to the left is because whatever's in brackets, you're going to pull it out and it's going to go the opposite direction. So this is a positive 2 in brackets. You're going to pull it out as a negative 2. which means you've moved 2 spaces left. So what we're actually comparing is where the start point is. Sine x, the red graph, starts at 0, 0. The other graph didn't. It moved 2 left, and it's starting at negative 2, 0. So that's all this is telling us. This tells us it moved 2 to the left, and it's starting at negative 2 now instead of at 0. Okay, so that's what that's telling us. It moved the wave. Any questions about what that C value is going to do? What if I put a negative in the bracket? What do you think it's going to do? It's going to go to the right, exactly. So you're going to go the opposite direction. All right, let's take a look at what that D value does. So we're going to change our C value back to just being C. So no brackets. If you have no brackets, that means there's no C value. So I'm removing brackets, and now I'm just going to put plus 5. What happened to our blue graph? That's right, the y-intercept changed. It moved it vertically up on the y-axis. Nothing else about it changed because I didn't change the A, the B, or the C. All I changed was the D. So, is this guy going to touch x at all? No, the blue one's not going to touch the x-axis at all. Okay? So that's how the parameters change. So we're just going to write ourselves a little note about each one of these. So, if the A changes, so the amplitude is the height of the wave changes. Okay, so the amplitude, if you change that number, the height of your wave will change, how high and how low it goes. When we change the B value, this changed the period. So, it affects how many waves you see. So if you see lots of waves, it means it's going fast. If you see less waves, it's going slower. Okay, because it's changing the period, how long it takes to make one full turn. Because that's what period is, one full turn. Okay, so the amplitude changes your height of your wave. The B value changes the period. It affects how many waves we see. So it affects the speed if we're talking about a vehicle and problem solving. It changes how fast it's going. The C value shifted left if, in brackets, it's a positive number. And vice versa. It will go left, shift right, shifted right, if a negative in the brackets. Okay, but the C value is always contained in the brackets. Okay, so the C value is just going to shift it left or right. That's all it does. So if it's a positive in brackets, it's going to move it left. If it's a negative in brackets, it's going to move it right. And then we're going to look at our D value. The D value change the y-intercept, which is equal to the midline. So it changed its midline. It vertically shifted up. So it's the vertical shift. C is the horizontal shift. Okay, I'll give you a minute to write that down. Push pause down, play when you're ready. Okay, we're going to take a look now. These ones just show us different examples. What if we affect the A value, the B value, and the C value? Well, if I change the A value, let's pretend I change the A to a 2. Where should the bracket be? It should be between the word sine and the letter B. It should be between sine and the letter B. Remember, they're going to do this on purpose. You just literally eliminate the other bracket. You do not multiply the digit in. So we're going to change in the first equation. We're going to put A as 2. We're going to put B as, let's go with 2. And we're going to put C as -3. Okay? So that's what's going to be in brackets. Let's take a look and see what our graph is going to show us. Any predictions to begin with? Any predictions about what this should show us with our amplitude? So remember, we're comparing everything to sine x. Okay, so I've got now 2 sine x. Oh, I'm changing that to a 2x -3. Okay? So we're comparing sine x, and I'm going to make it a thicker line. Okay, so make your top line thicker. So we're always comparing to our base graph sine of x. And then we're going to change our amplitude to 2. In front of sine x, it's a 1. We change the number in front of x to a 2. In the above 1, it's a hidden 1. And now we're changing our c value, which was 0 in the above 1, to a -3. Now we're going to hit, just hit zoom 6 to show you everything. Okay, did everybody see your waves go through? So, I'm just going to change my window. I'm going to change my y min and max. So I'm going to change my y min to -4 and my y max to +4. Okay, that will help. Now we can see the waves a lot more clear. So what are you noticing about the lighter graph compared to the darker graph? It's going faster. There's more waves. Does it have the same period? If it's got more waves, it does not have the same period. The reason we know it doesn't have the same period, even just coming back here, we changed the number in front of x to a 2. It was a 1 before. So what happened to the graph? Well, it's going faster. Did it go left or right? Did it shift from 0? It did shift from 0. Which way did it move? To the right. How far? 3 to the right. All right. Okay. Now we're going to change. We're going to go into y equals. And at the end of this guy, we're going to change on here, we're going to change it to a +2 now. So we're going to change the d value to +2. So we've changed every number now. So now we're going to graph. Now what happened to the graph? It moved up vertically because I changed that d value. Okay? So when I change the d value, that means my midline changes. I'm changing the maximum point and I'm changing the minimum point just by changing that d value. Okay? So that's what's going on with those. Now, if I want to find the starting point of any graph, the start point, if you're only given an equation, the start point comes from this, right here. -c divided by b is your x-coordinate, d would be your y-coordinate. So this is your x-coordinate right here, and your y-coordinate right there. That would be your start point. So for example, if I've got y equals 4 sine 0.5x plus 2 minus 3. Let's just pretend that's my equation. So I've got a 4 for my A, a 0.5 for B, 2 for a C, and -3 for D. So here I need -c over B. All the -c means is take the c out as the opposite sign. So in brackets, c is a +2. He's going to come out as the opposite, -2. So I'm going to have -2 divided by, what's my B number? 0.5. Okay, now that's going to be my x-coordinate. What's -2 divided by 0.5? -4. So that's my x-coordinate. What is my d value? -3. So my d value This is our start point. That'll be my x-coordinate, that's my y-coordinate. Okay, so that's how you're going to find a start point. It's very rare they ask us for a start point, but you still need to know how to find it. Okay? Now we're going to go just strictly to an equation. We're not going to graph it. We're just going to analyze an equation. Okay? By knowing what every single letter does. The A, the B, the C, the D. And I will remind you, don't you worry. So, we're going to go to the chart on the bottom of your page. Okay? Chart on the bottom of our page. The very first thing we're going to do is we are going to label the A, the B, the C, and the D. If there's no brackets, there's no C. So this guy's A, B, and D. Now, it's telling me my domain. My domain is going to help because that's going to help me find my period. All right. A value, 2. B value, 4. C value, doesn't have one. D value, 1. Now this is where we're going to just write some numbers here. So let's take a look. Amplitude is the A value. Period, it's not the B value. It's 2 pi divided by B, or 360 divided by B. Now how do we know if we're going to be using 2 pi or 360? That's right, whether it's degree or radian. And we were shown up here that we're in degrees. Okay, I told you that was going to help us for our period. It's in degree mode. So since this graph is in degrees, we must take 360 and divide by B. We're not going to use the 2 pi. So we're going to go 360 divided by our B value, which is 4. So if I go 360 divided by 4, I'm going to get 90 degrees. So 90 degrees is my period. The B value? No, the B value is the number that sits in front of the X. The amplitude's the A value. Now, horizontal shift is the C value. Okay, so these go in order. Amplitude is A. Period is not the B. You use the B to help you find it. Horizontal shift is C. Well, we don't have one, so we don't have a C. And then equation of our midline, that's our D value. So once the equation, so we have to start with Y equals. Well, what's our D value? 1. So we're going to say 1. Now, I'm going to show you how to find your maximum and minimum using your D and your A values. If you want to find your max, it's going to be D minus A. Or sorry, plus A. If you want to find your min, it's D minus A. Okay? So that's how you do it if you've only got an equation with you and no graph. So if I want my maximum point, my max point is going to be my D value plus my A value, which is going to be 3. My min value is my D value minus my A value, which is -1. So now I know that on my graph, it's going to go from -1 all the way up to +3. And that's where it's going to do its waves. Okay? That's what it tells me about it. Okay, I'll let you finish writing that down, and we're going to move to the next one. All right, let's take this second example. Again, we start by labeling the A, the B, the C. So we've got A, B, and C. Remember, the B value, just move the bracket and it should be out back. Okay? You do not multiply that 2 in. So now, our B value is a 2, A is 3, and C is that a -45? Okay, but we got to pull them out of brackets. It's going to be a +45 degrees. Do we have a D value? No, that's like saying 0. So it's like saying +0. So the midline is 0. If the Y is 0 for a midline, what is Y is 0? What line is that? The X axis, the X line. Okay, so we know that the midline is the x-axis. Okay, it has to be because there's no d value. All right, now we're going to go back down and we're going to identify these other features. So, amplitude, a value, 3. Period, 360 divided by 2. So how big is it? 180 degrees, good. Horizontal shift, how far did it move? 45, but which direction? To the right, because he's positive. Okay, remember, negative in brackets moves to the right because you take them out. I just put an R for right. Wait, if it's a horizontal shift, if they ask for the shift, you have to tell them which way it went. Okay, you can't just put plus 45, because that still doesn't tell you for sure if you know if it goes right or left. Okay? Yeah. Equation of the midline, y equals, same as your d value. This guy's your d value. So that's going to be 0. Horizontal shift, that was our c value. So you can see they use every parameter that's going to describe something about the graph. Okay, how big is our maximum point here? How big is our max? Well, we're going to take our d and we're going to add our a. That's going to give us 3. Our min, 0 minus 3, is going to give us negative 3. So our max and mins are plus and minus 3. This will happen all the time. The answers will be identical, positive and negative, if the d value is 0. So if your d value is 0, amplitude's 90, your max is 90, min's negative 90. Okay, whenever your d value is 0, just take your a value, one of it's positive, one of them's positive, one of them's negative. Okay, for max and min. Okay, the next question. This one is a regression, but take a look. It's comparing two different places. It's comparing Flin Flon to Lethbridge. And again, it's a regression equation. And the sinusoidal curves are perfect for describing seasonal weather. So they do it quite frequently, and this is how they have programs that will do it for them in their meteorology places. I don't know where they are, but they have programs that do it for them. We know how to do it with sine reg. So the number of month will go into list 1 always. You will put Flin Flon into list 2. Okay? So you've got your list 1, list 2. You're going to do a sinusoidal regression to get that answer. Then you're going to erase Flin Flon in list 2, and then you're going to put Lethbridge in list 2. Okay, and do the same thing. List 1 stays the same, the months 1 to 12. There's a question similar to this on your unit assignment. It'll be done the same way. I'll give you a couple minutes to do your regressions. Push pause now and play when you're ready. Okay, here's our 2 equations that we got. On April 1st, it wants to know for our 4th month, it wants to know our average temperatures. Well, your average temperatures, if we look on our chart, the chart was 1.8 and 6.0. So the average temperature for Flin Flon was 1.8. So it's nearly freezing. And Lethbridge was 6.0. So it was quite a bit warmer. Whenever it does ask us, though, about our average temperatures, it's asking about the d values. So the average temperature in that time period, well, Flin Flon's average temperature is negative 1.88, 5.88. Oh, I said that wrong again. Negative 1.588. So that means in degrees. That's degrees Celsius. So that's minus 1.6 degrees. That's its average temperature in Flin Flon. Yay, let's move there, right? Lethbridge is a lot warmer. His average temperature is 5 degrees, 5.14 degrees. Now let's find the maximum temperature and the minimum temperature for both. So if I want my max temperature is going to be my D plus A, and that's going to give me negative 1.588 plus 20.249. So what's that going to give me for my maximum temperature? What is the maximum temperature for Flin-Flon? Negative 1.588 plus 20.249. Who has it done? Yes, Marissa. 18.661. Okay, and remember that's degrees Celsius. So its average temperature is about 19 degrees. Okay? Now, what would be the minimum temperature? Well, we're going to subtract it. So we're going to have minus 1.588, and we're going to subtract 20.249. Well, its average temperature in the winter is negative 20 what? You're adding negatives. It should be negative 21.837. That's degrees. That's cold. So that's the average temperature in the winter, negative 21 degrees, almost negative 22 all the time. Not fun. Let's find Lethbridge, max and min. So, max, T plus A, 5.14 plus 13.039. So how warm is it in Lethbridge for its maximum temperature? 18.179. Okay, and now we're going to do its min temperature, which is D minus A. Okay, D minus A. Negative 8 degrees almost. So one of them is a lot warmer than the other. Okay, that's basically what it's showing us, and it's showing us average temperatures for certain time periods. Now, if I wanted to know the period of our graph, how would you find the period of these functions right here? First thing we're going to do is look at the C value. Is the C value a degrees or is it a radian? Does it show us a degree symbol? No, so it's radians. So that means since our numbers are all in radians, well, no, we can still find it out in radians. That's fine. But all we've got is that the reason I asked if it's degrees or radians, because to find the period, you're either going to take 2 pi and divide by the b, or you're going to take 360 divided by b. It always depends on what your C value is. So if it's a radian, you're taking 2 pi divided by b. So for Flin-Flon's period, we're going to go 2 pi divided by b. Now, because 2 pi is on the top of a fraction, it must be put in brackets. Or solve it first. 2 pi, enter, divide by. So, put it in brackets if you have to. We're going to have 2 pi divided by our b number, which in this case is going to be 0.472. Okay? Should be close to around 11 or something. And then Lethbridge, period. We're just going to go to, you can go to 1 decimal place on this one. What's our period? Sorry? 13.3. Okay. So 13.3. That's how long it takes to make a cycle. Well, let's take a look at the next one. What's the other guy? We're talking about Lethbridge is 0.503. 0.503. And what do we get? This one should be closer to 12 something. 12.5? Okay. Now, how many months are in the year? 12. So our period should have come around 12 no matter what. We have numbers that are a little bit higher. That's okay because we have actual decimals that have been rounded. That's why. That they would have been accurate. We should get 12 for our period. Okay, does it make sense why the period is 12 months? Yeah. That's right. That's the length of time they measure. Okay? All right. Now, we'll be off a little bit, again, because we have leap years where February is 29 days. That's why these numbers will be off a little bit. Plus, we've rounded those decimals that we're dividing by. Okay? All right. Now we're going to take a look at a couple different questions. and we're going to analyze and try to draw graphs given the features of the graph. So let's take a look at the next one. This one says, here's our general formula, and it says write our equation, but it tells us we have no phase shift. No phase shift is a C value. That means we have no C. Now it's going to tell us different things. So we don't have to worry about a C value, and that's something that we don't ever have to calculate. They either give it to you or they tell us we don't need it. Okay? So, again, we're going to start with y equals. We're going to put a number in front of sine, a bracket, a number in front of my b, and then I'm going to have my C value. They tell us we have no C value, pardon me, sorry. So it's just going to have this. Whoopsie. B value and then X. And then we're going to have our D value. So on top of each of those blanks, we're going to put a number. Inside my brackets, there's no C value. That's why I just enclosed the X. But in front of the X, we have to put the B value. So the A value goes here, B goes here, D goes there. So which number, my 7, my 2 pi, or my -4, which one is the A value? The amplitude. Okay? A is amplitude. Starts with the letter A. Okay, so we've got our amplitude. We got that taken care of. It says the period is 2 pi. Well, if we want to find the B value to put into an equation, we do this. It's just rearranging the equation. 2 pi divided by B is period. So if I want to find the B value, these two switch places. All I do now is take 2 pi, divide by period, and that equals the B value in the equation. You're just rearranging this equation. So they tell us our period is 2 pi. So we're going to take 2 pi and divide it by itself, 2 pi. So right here, we're taking 2 pi divided by 2 pi. Well, what's something divided by itself? 1. So we have a B value of 1. Okay, 2 pi divided by 2 pi. Then it says we have the equation of our midline is y equals -4. I've got one last spot. He's going to go -4. The midline never changes his sign. If he's a negative, he stays negative. The only one that would change would be the C value phase shift, but they're going to tell us that one. Okay, so we've created our equation. If they asked us for our max and min, could we find the max and min from that? Which values do I use to find max and min? D and A. It's always D and A. Right? We're either going to add them or we're going to subtract them. Amplitude, you can always remember this as well, please. The A value and B value are always positive no matter what. C and D can be negative, no problem. But A and B will always be positive. So if it's a multiple choice question and they're asking about the A or the B value, and there's negative answers, cross them off. A and B cannot be negative. Okay? All right, let's try and find the equation for the characteristics in the next section. So letter B. I'll give you a couple minutes. You guys try this one. Okay, you guys try B. Do it exactly the way we just did A. Okay, push pause now and play when you're ready. Okay, let's see if we got everything in the right spot. Y equals amplitude of 2.5. There's our A value. Sine, our B value, we're taking 2 pi divided by our period of 1. Well, that's just 2 pi. So since pi is a run-on decimal, it's irrational, we leave pi as the pi symbol. So you're just going to write it as 2 pi in front of the x. Okay? We have no C value, and then we need a midline, our D value. It says a value of 6. So can I just write 6 by itself? You need to connect with a plus sign. Good. That tells us it's a positive 6 that raised it vertically 6 up on the y-axis. Okay? All right. The next thing we're going to take a look at real quick is we're going to take a look at how do you match graphs. This section here, you guys can fill these ones out. These are exactly what we've been doing. You have to create the equation based on what they give you for this. Okay? Again, the C value we never figure out. So you don't have to worry about that. Just A, B, and D. Okay? We'll take a look at that later. I want to look at matching for a moment. Whenever you're matching, the rule for matching is to find the amplitude and period. Always match the amplitude and period first. So, on both graphs, create and find your amplitude and period, and find the ones they match here. That's all you're doing. Okay? So I'll give you a couple minutes. Push pause now and play when you're ready. Okay, as you can see here, we've found the amplitude and the maximum and minimum of each. That means our t values are identical and our a values are identical. Okay, you got a few minutes to work on these questions. As you can see, I've put them each into my y equals, but I've made sure that only one of them is selected to graph. How do I know which one? It is the one where the equal sign is dark. Now what I'm going to take a look at it, I'm going to compare my graphs. We were able to cross off the section number 2, that second possibility, because the amplitude was wrong. The minute we saw the wrong amplitude, we got rid of that question. Now the other amplitudes, they all match, they're all 4, and all the t values are all 1. So now we have to check period. Well, the period of the first one is 2 pi. The period of the bottom 2 is 2 pi over 3. So we have to figure out which graph matches. So if we take a look at the graph, I'm going to look at my very first graph, and I've got my scale. If we take a look at our windows, I've gone to 720, and then I've gone 90 as my scale. So looking at my graph again, that means each notch on my graph is 90. So if I want to trace one full period here, it is going to be ending at 90. It's going to be ending at 360. So the period for my first one here is 360. So 2 pi is 360 degrees. So whichever one is full 360 degrees, that is the equation that's going to match. So let's just take a look. Which one was matching? Well, if I look at the very first one, if I were to trace one period's right there. That's not 360 degrees. But if I trace one period over here, one period ends at 360 degrees. So that means I know graph 2 matches equation 1. So equation 1 is graph 2. Now I need to match equation 3 or 4. Which one matches the graph 1 that I've got there? Well, if I take a look, the periods are different. So let's take a look in my y equals. I'm going to change which one's going to be graphed. I'm not going to graph that one. I'm now going to graph the second one. I'm going to make it black and select it. So when I graph this one and I take a look, this one has a period of, if I go down and back up, it's got a period of just over 90. Let's take a look at the second one. But also take a look at where it's starting. This one starts below at a minimum down here on my graph. So if I take a look at my graph on the actual graph page, it starts at my y-intercept and then it goes down. The one that I just saw, it started way down here and then it started to go up. So let's check the third example, example number 4 here, and let's see if that one matches. So again, we're checking to see which graph's matching. We're just going to clear this guy out and we're going to graph the third one. So here's my number 4. Now, if I look at my number 4, is this one showing the exact same one? Well, is it a cos graph or is it a sine graph? That's the difference. One of them has sine, one of them has cos. So if I look at graph 1, is it a sine graph or is it a cos graph? Well, if I look at the graph that I just drew in here, and if I check my y equals, he's 4 cos 3x. But if I were to put in that other one again, for sine 3x minus 60 plus 1. We see which graphs, that one is starting at the other end. So this one is actually not going to match our cos graph. So the one that actually matches is graph 3. So graph 3 is going to match. So graph 2 and 4 were not matches, but graph 1 and 3 were matches. Equations 1 and 3. Again, all these ones are checking what has happened to our transformation here. The only thing that's happened is the original. The original is the light graph, the shaded, the darker graph, is the one that has been transformed or moved. So our original here starts at 0, 0, and then it continues. We've got a period of 8. Well, this guy's period didn't change. All he did was he shifted over 2 to the right. So we have a horizontal shift. Of 2 to the right. If we take a look at the letter B has moved up. So this one is a vertical shift of 2 up. If I take a look at letter C's done a few things. It's gone to the right and it's gone up. So we have a horizontal and a vertical shift. Okay, there's 2 shifts on that one. Okay, again, I'll leave these next few questions for you. These ones are practice. Again, you are matching. Take a look at the next few. This one, you want to find the equation and using the graph. The following ones, these are your review. This shows you exactly how to calculate your period, where to find your start points. This now concludes lesson 3.6.